नॉइज पोल्यूशन से स्टार्ट करना था. सो डिस्टर्बेंस प्रोड्यूस्ड इन द एनवायरनमेंट ड्यू टू अनडिजायरेबल साउंड एंड हार्श साउंड ऑफ level above 120 decibel from various sources such as loudspeaker, siren, moving vehicles, etc. is called noise pollution. ठीक है. सो 120 डेसिबल से जब साउंड लेवल ज्यादा हो जाता है तो उसको हम लोग नॉइज पोल्यूशन कहते हैं. Now, a constant hearing of sound of level above 120 decibel can cause headache and permanent damage to the ears of the listener. The safe limit of level of sound for hearing is from 0 to 80 decibel. Sound of level 30 decibel to 10 decibel has a soothing sensation, while the sound of level 0 decibel represents the lower limit of hearing. Now, pitch or shrillness and frequency. So, second characteristics of sound is pitch, which is also called shrillness, and it is directly proportional to frequency. So, pitch is that characteristics of sound by which an acute or shrill note can be distinguished from a grave or flat note of same loudness. तो loudness अगर same रहता है, pitch जो है दो different sound को differentiate करेगा. One with a shrill note and other with a grave note. Now, pitch is considered only if reference to the musical sound, only pitch is considered only in reference to the musical sounds. Each musical note has a different pitch. So, if the pitch is high, the sound is shrill, and if the pitch is low, the sound is flat. So pitch of a note depends on its frequency. Two notes sounded on the same instrument with same amplitude will differ in pitch when their variations are of different frequencies. More the frequency of wave, higher is its pitch, and less the frequency of wave, lower is its pitch. ठीक है. So फ्रीक्वेंसी हाई होगा तो हायर पिच होगा, श्रिल साउंड होगा. फ्रीक्वेंसी लो होगा तो लो पिच साउंड होगा और ग्रेव साउंड उसको हम लोग बोलते हैं. So more the frequency of wave, higher is its pitch, and less the frequency of wave, lower is its pitch. Now, examples of change in pitch in string instrument such as piano, violin, and guitar, the frequency of vibrations of a string depends on the tension and thickness of a string. They can produce notes of different pitch by changing the thickness and tension of the string. A note of higher pitch can be obtained by vibrating the string under high tension or by vibrating a thinner string. तो basically तुम देखोगे जो भी स्ट्रिंग्ड इंस्ट्रूमेंट्स होते हैं उन सारे स्ट्रिंग इंस्ट्रूमेंट में आप इस तरह से लेट्स से ये हमारा गिटार या कुछ भी है और इसमें कई सारे स्ट्रिंग्स लगे हुए हैं, राइट. अब यहाँ पे जो ये जो थिकनेस है सारे स्ट्रिंग्स का अलग, एक्सक्यूज मी. सो जो थिक स्ट्रिंग है उससे जो साउंड होगा ना वो लेस श्रिल प्रोड्यूस होगा, फ्रीक्वेंसी उसका लेस होता है. जो थिनर स्ट्रिंग होता है उससे जो साउंड प्रोड्यूस होता है उसका फ्रीक्वेंसी हाई होता है, हाई पिच्ड साउंड होता है. उसके अलावा टेंशन इंक्रीज करने से, टेंशन कैसे इंक्रीज करते हैं, यहाँ पे फ्रेट बोर्ड जो होता है उस फ्रेट बोर्ड पे अगर तुम अपने फिंगर्स रखोगे, राइट, तो उससे ये वाला जो पर्टिकुलर स्ट्रिंग है उसका एक तो लेंथ वेरी करता है ना, लेंथ वेरी करता है. और उसका अगर हम लोग पीछे से स्क्रू जो होते हैं यहाँ पे, ये स्क्रू को टाइट करोगे, राइट, तो उसके टेंशन को आप चेंज कर सकते हो, एंड डिपेंडिंग ऑन दैट द फ्रीक्वेंसी चेंजेस एंड द पिच ऑफ द साउंड चेंजेस. क्लियर है बच्चों? So a note of higher pitch can be obtained by vibrating the string under high tension or by vibrating a thinner string. In case of a flute, a lower note is obtained by closing some more holes so that the length of the vibrating air column increases. तो जैसे एक फ्लूट में कई सारे होल्स होते हैं, है ना. सो फ्लूट में कई सारे होल्स होंगे यहाँ पे टॉप पे, तो आप जिसको भी क्लोज करते जाओगे, जैसे यहाँ पे क्लोज करते जाते हैं तो उसका लेंथ इंक्रीज होता जाता है, राइट. तो उससे लोअर नोट प्रोड्यूस होता है. मोर सम मोर होल्स सो दैट द लेंथ ऑफ द वाइब्रेटिंग एयर कॉलम increases. Now, as the water level in a pitcher kept under a water tap rises, ठीक है, तो अगर हमारे पास एक ये पिक्चर है, इसमें जो, ठीक है, सो इसमें जो पानी इससे भर रहा है, तो जैसे जैसे ये वाटर लेवल इस पिक्चर में इंक्रीज करता है, सो एज द वाटर लेवल in a pitcher kept under water tap rises, the length of the air column decreases. तो यहाँ पे जो length of air column है, पानी जैसे जैसे rise करेगा, length of air column decrease करेगा. So the frequency of sound produced increases. That is, the sound becomes shriller and shriller. Thus, by hearing the sound from a distance, one can get the idea of water level in the pitcher. तो पानी भर गया है नहीं, ये दूर से ही पता चल जाएगा आपको, है ना. जैसे जैसे पानी भरता जाएगा, उसका फ्रीक्वेंसी इंक्रीज करता जाएगा और श्रिल साउंड प्रोड्यूस होता जाएगा. तो once it is completely filled, we will come to know by listening to the sound of that as well. The voice of a woman is usually of higher pitch than of a man. Now, subjective nature of pitch and objective nature of frequency. तो जैसे वहाँ पे लाउडनेस और इंटेंसिटी था, यहाँ पे, है ना, पिच और फ्रीक्वेंसी है. सो पिच इज नॉट सेम एज फ्रीक्वेंसी. पिच डिपेंड्स ऑन द सेंसेशन एज परसीव्ड बाय द लिसनर. So pitch is not same as frequency. The pitch depends on the sensation as perceived by the listener. It may be different for a sound of a particular frequency to the different listeners. तो listener के ऊपर depend करता है, इसीलिए इसको on the, excuse me. So that is, pitch is of subjective nature. ठीक है. Pitch is of subjective nature. On the other hand, frequency is a measurable quantity. It depends on the source producing the sound. It has a definite value for a given sound which is equal to the frequency of its source. It has nothing to do with the listener. So frequency is of objective nature. Now third wala point है quality or timbre and waveform. So quality or timbre of a sound is that characteristic which distinguishes the two sounds of the same loudness and same pitch, but emitted by two different instruments because of change in their waveforms. Now, figure shows the wave pattern of two sounds of same loudness, that is same amplitude, and same pitch, that is same frequency, but emitted by two different sources. They produce different sensations in our ears because they differ in waveform. One is a sine wave while other is a triangular wave. तो waveform अलग अलग होने की वजह से जो sound है वो different sound produce होता है. The quality of a musical sound depends on the waveform. So thus the quality of a musical sound depends on the number of subsidiary notes and the relative amplitudes present in it along with the principal note. अब ये जो देखो, जैसे यहाँ पे वेव फॉर्म ऑफ ट्यूनिंग फॉर पियानो है, तो इसीलिए इन दोनों का जो साउंड है वो डिफर करेगा. नाउ म्यूजिक एंड नॉइज, ये तो हट गया है ना सिलेबस से, म्यूजिक एंड नॉइज तुम्हारा. So all the sounds, थोड़ा सा ही है, बता ही देते हैं. So all the sounds which produce the sensation of hearing can be divided into two categories. One is music and other is noise. Music, it is pleasant, continuous and uniform sound produced by the regular and periodic vibration. Noise, the sound other than musical sound, is called noise. It is a sound produced by an irregular succession of disturbances. It is usually a discontinuous sound. Now, comparison between the music and noise. म्यूजिक में यहाँ पे इट इज, so music it is regular, smooth and pleasant to the ears. Noise it is harsh, discordant and unpleasant to the ear. Music is produced by the vibration which are periodic. Noise is produced by an irregular succession of disturbances. Music, all the component waves are similar without any sudden change in their wavelength and amplitude. Noise, the component waves change their character suddenly and they are of short duration. The sound level is low in case of music. In noise, the sound level is high. Music, the waveform is regular. Example, the sound produced by musical instrument. And noise, the waveform is irregular. Example, the sound produced by an aeroplane, road roller, uh, industrial machines, etc.
सर,
हाँ जी बेटा.
ये पता किस करते कि वो वेव फॉर्म किस टाइप का है?
वो तो सीआरओ से पता चलता है. एक कैथोड रो ऑसिलोस्कोप होता है, उसमें हम लोग इनपुट वेव जो आता है उसको देते हैं और उससे आउटपुट हम लोग जनरेट करते हैं, तो देखते हैं कि बेसिकली किस तरह से वेव का फॉर्म होएगा. बट हम लोगों को वो चीज़ नहीं करना है. हम लोगों को बेसिकली मतलब जैसे तुम कोई साउंड प्रोड्यूस कर रहे हो, उसमें देख रहे हो कि कैसा वेव फॉर्म होना चाहिए, वो तो सीआरओ से देख सकते हैं. बट हम लोगों को तो बस ये देखना है कि जो अलग अलग म्यूजिकल इंस्ट्रूमेंट होगा, इवन दो उसका लाउडनेस और जो फ्रीक्वेंसी है वो सेम है, वेव फॉर्म डिफर करने की वजह से साउंड जो है अलग अलग तरीके का प्रोड्यूस होता है.
यस सर।
साउंड के बाद हम लोग को लाइट वाला पोर्शन स्टार्ट करना है. लाइट में ये रिफ्रैक्शन ऑफ लाइट और रिफ्रैक्शन थ्रू लेंस और स्पेक्ट्रम. 2 मिनट दो, मैं स्टार्ट करता हूँ उसको उसको लेकर. जस्ट गिव मी. तो रिफ्रैक्शन ऑफ लाइट एट प्लेन सरफेसेस हम लोग को स्टार्ट करना है. चैप्टर 4. First, a refraction, law of refraction and refractive index. So nature of light in the same, the return of light in the same medium after striking a polished surface is called reflection of light. ये हम लोगों ने 9th क्लास में भी पढ़ा था कि किसी मीडियम से लाइट अगर रिफ्लेक्ट करके उसी मीडियम में वापस आ जाता है तो उसको हम लोग रिफ्लेक्शन ऑफ लाइट कहते हैं. The reflection of light rays obeys two laws. One is, तो laws of reflection जो है, पहला है the angle of reflection is equal to angle of incidence, and the incident ray, the normal at the point of incidence, and the reflected ray all lie in same plane. Okay. Now light has maximum speed of 3 into 10 to the power 8 meter per second in vacuum, and it travels with different speeds in different media. It travels faster in air than in water or in glass. The speed of light is 3 into 10 to the power 8 meter per second. In air, 2.25 into 10 to the power 8 meter per second in water and 2 into 10 to the power 8 meter per second in glass. Okay. Now, speed of light remains constant in a transparent homogeneous medium. While passing from one medium to other, if light slows down, the second medium is said to be optically denser than the first medium. And if light speeds up, the second medium is said to be optically rarer than the first medium. तो basically जब एक मीडियम में लाइट जाता है और उसका स्पीड स्लो हो जाता है मतलब वो डेंसर मीडियम में गया है और अगर एक मीडियम में जाने पे उसका स्पीड फास्ट हो जाता है मतलब रेयर मीडियम में गया है रिफ्रैक्शन ऑफ लाइट So while passing from one medium to other, if light slows down, the second medium is said to be optically denser than the first medium. And if light speeds up, the second medium is said to be optically rarer than the first medium. Now, refraction of light, partial reflection and refraction at the boundary of two different media. So optical density has no relation with the density of medium. Kerosene is less dense than water as it floats in water, but it is optically denser than water, right? Similarly, optical density of a medium depends on the speed of light in that medium, while the density of a medium depends on its intermolecular separation. तो जो normal density है वो optical density से it is quite different from optical density. So optical density of a medium depends on the speed of light in that medium, while the density of a medium depends on its intermolecular separation. In a transparent homogeneous medium, light travels in a straight line path, but when a ray of light traveling in one transparent medium strikes obliquely at the surface of another transparent medium, a part of light goes back to the same medium, obeying the law of reflection, and is called the reflected light. The remaining part of light enters into the other medium and travels in a straight path different from initial direction and is called the refracted light. Thus, at the boundary separation, the two media, thus at the boundary separating the two media, light suffers a partial reflection, and so thus at the boundary separating the two media, light suffers a partial reflection and partial refraction. ठीक है तो किसी भी बाउंड्री पे देखो ये जो इंसिडेंट लाइट है partially it will be refracted and partially it will be reflected. The change in direction of path of light, so change in direction of path of light when it passes from one transparent medium to another transparent medium is called refraction. The refraction of light is essentially a surface phenomena. तो हमेशा एक सरफेस पे ही होगा जहाँ पे मीडियम एक मीडियम से दूसरे मीडियम में चेंज करेगा वहीं पे रिफ्रैक्शन होता है और जब एक ट्रांसपेरेंट मीडियम से दूसरे ट्रांसपेरेंट मीडियम में जाने पे जो चेंज इन डायरेक्शन ऑफ पाथ ऑफ लाइट होता है उसको रिफ्रैक्शन कहते हैं और वो चेंज इन डायरेक्शन होता है क्योंकि स्पीड ऑफ लाइट डिफर करता है दोनों मीडियम. Now, it has been experimentally observed that when a ray of light travels from a rarer medium to a denser medium, say from air to glass, it bends towards the normal as shown in the figure. So when R is less than I, the deviation of the ray from its initial path is delta, which is equal to I minus R. When a ray of light travels from a denser medium, so when a ray of light travels from a denser medium to a rarer medium, say from glass to air, it bends away from the normal, that is R is greater than I, as shown in the figure. The deviation of the ray is then delta is equal to r minus I. The ray of light incident normally, right? So ray of light incident normally on the surface separating the two media passes, sorry. So ray of light incident normally on the surface separating the two media passes undeviated, straight pass kar jata hai. That is, such a ray suffers no bending at the surface. Thus, if angle of incidence I is equal to 0 degree, angle of refraction R is also 0 degree as shown in figure. The deviation of the ray is 0, that is delta is equal to 0 degree. Now, cause of cause of refraction or cause of change in direction. When a ray of light passes from one medium to another medium, its direction or path changes because of the change in speed of light in going from one medium to another. In passing from one medium to other, if light slows down, it bends towards the normal. तो जब एक मीडियम से दूसरे मीडियम में जाता है और लाइट का स्पीड स्लो हो जाता है तो it bends towards the normal. And if the light speeds up, it bends away from the normal. If the speed of light remains same in passing from one medium to another, the ray of light does not bend. It passes undeviated. Now, law of refraction. So there are two laws of refraction as well. The refraction of light obeys two laws of the refraction of light obeys two laws of refraction, which were given by the Dutch scientist Wilbrod Snell. So they are known as Snell's law after his name. Repeat again. These laws are the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. Second, the ratio of the sine of the angle of incidence I to the sine of the angle of refraction R is constant for the pair of given media. That is, mathematically, sine I by sine R is equal to constant, which is refractive index of the medium, of the second medium with respect to first medium. So mu 2 1 means refractive index of medium 2 with respect to 1. The constant mu 2 1 is said to be refractive index of the second medium with respect to first medium. Here the Greek letter mu is the symbol used for refractive index. Now, effect on speed v, wavelength lambda. So effect on speed v, wavelength lambda, and frequency f due to refraction of light. So when a ray of light gets refracted from a rarer to a denser medium, the speed of light decreases, while if it is refracted from a denser to rarer medium, the speed of light increases. The frequency of light depends on the source of light, so it does not change on refraction. So frequency ना तो हम लोगों ने देखा था कि रिफ्लेक्शन में भी चेंज नहीं करता है, रिफ्रैक्शन में भी चेंज नहीं करता है. Speed of light v in a medium, the wavelength of the light lambda in that medium, and frequency of light f are related as speed is equal to wavelength by time period. 1 by time period को हम लोग frequency लिख लेते हैं. So ठीक है, 1 by टाइम पीरियड को हम लोग फ्रीक्वेंसी लिख लेते हैं. सो उसको हम लोग v इज इक्वल टू एफ इंटू लैम्डा लिख सकते हैं. सो फ्रीक्वेंसी f इज इक्वल टू v अपॉन लैम्डा. So when light passes from a rarer to a denser medium, the wavelength decreases since speed of light decreases but its frequency remains unchanged. Now, when light passes from a denser to a rarer medium, the speed of light increases and hence its wavelength increases. Now, refractive index. The refractive index Now, refractive index of a second medium with respect to the first medium is defined as the ratio of sine of the angle of incidence in the first medium to the sine of the angle of refraction in the second medium. So, refractive index has no unit as it is the ratio of two similar quantities. Right. Now, speed of light in different media, relationships between refractive index and speed of light. So, a refractive index of a medium is generally defined with respect to vacuum or air, and it is called the absolute refractive index or simply the refractive index of the medium. It is denoted by letter mu. तो किसी भी मीडियम का एयर के रेस्पेक्ट में अगर रिफ्रैक्टिव इंडेक्स निकालते हैं तो उसको उसका एब्सोल्यूट रिफ्रैक्टिव इंडेक्स उस मीडियम का बोलते हैं. ठीक है. और इसको हम लोग जनरली म्यू से रिप्रेजेंट करते हैं. Refractive index of a medium is defined as the ratio of speed of light in vacuum to the speed of light in that medium. So mu is equal to c by v करके फॉर्मूला होता है. तो speed of light in air or vacuum and speed of light in that medium v. The refractive index of a transparent medium is always greater than 1. It cannot be less than 1 because speed of light in any medium is always less than that in vacuum. So that means V is less than C. Obviously, mu is equal to 1 for air or vacuum. Now, example पहला अगर हम देखें, the speed of light in air is 3 into 10 to the power 8 meter per second, and in glass it is 2 into 10 to the power 8 meter per second. Therefore, the refractive index of glass with respect to air is mu is equal to C by V करेंगे तो 1.5 आ जाएगा. ठीक है. और speed of light in water is 2.25 into 10 to the power 8 meter per second. So the refractive index of water is mu water with respect to air is equal to 3 into 10 to the power 8 by 2.25 into 10 to the power 8. So that is 4 by 3 or 1.33. In general, the refractive index of second medium with respect to first medium is related to the speed of light in two media as follows. So refractive index of medium 2 with respect to 1, that is mu2 by mu1 is equal to speed of light in medium 1 by speed of light in medium 2, inversely proportional, where mu2 1 represents the refractive index of medium 2 with respect to medium 1. And if v1 is the speed of light in medium 1 and v2 is the speed of light in medium 2, then from equation 3, mu2 1 is equal to v1 by v2 or c by v2 by c by v1 or mu2 by mu1. Here mu1 and mu2 represents, so mu1 and mu2 represents the refractive indices of medium 1 and 2 respectively. Note that if the refractive indices of medium 1 and medium 2 are same, the speed of light will pass from medium 1 to medium 2 without any change in its path, even when the angle of incidence in medium 1 is not zero. Now, conditions for a light ray to pass undeviated on refraction. So, a ray of light passes undeviated from medium 1 to medium 2 in either of the following two conditions. First, when the angle of incidence at the boundary of two media is zero, as shown in figure. Second, when the refractive index of medium 2 is same as that of medium 1. Now, relationship between wavelength in two medium. So if a ray of light of frequency f and wavelength lambda suffers refraction from air, so speed of light is c, to a medium in which the speed of light is v, then the frequency of light in medium remains unchanged, equal to f, but the wavelength of light changes to lambda dash, such that in air f is equal to c by lambda and a frequency is equal to c by lambda, right? And in medium f is equal to v by lambda dash. Now because frequency remains same, तो दोनों frequency को equate कर देंगे, c by lambda is equal to v by lambda dash. So that means lambda is equal to v by c into lambda. So c by v mu होता है, तो lambda dash is equal to c by v C by V is equal to mu, the refractive index of the medium. So that's why lambda dash will be given as lambda by mu. Now, factors affecting the refractive index of a medium. So there are certain factors which affect the refractive index of a medium. First is nature of the medium. So factors affecting the refractive index of a medium. So refractive index of a medium depends upon the following three factors. So first is nature of the medium on the basis of nature of the medium on the basis of speed of light. So less the speed of light in medium as compared to that of air, more is the refractive index of the medium. Second, physical conditions such as temperature. With increase in temperature, the speed of light in medium increases, so the refractive index of medium decreases. The color or wavelength of light, the speed of light of all colors is same in air or vacuum. But in any other transparent medium, the speed of light is different for different colors. So a given medium, the speed of red light, so in a given medium, the speed of red light is maximum and that of violet light is least. Therefore, the refractive index of that medium is maximum for violet light and least for red light. So mu v is greater than mu r. The wavelength of visible light increases from the violet to the red end. So refractive index of a medium decreases with the increase in wavelength. Now, principle of reversibility of the path of light. So according to this principle, the path of a light ray is reversible, right? So in figure, a ray of light AO is incident at an angle I on a plane surface SS dash, separating the two media 1 and 2. Okay. It is refracted along OB at an angle of refraction R. The refractive index of medium 2 with respect to medium 1 is. So refractive index of medium 2 with respect to 1 अगर हम लोग करेंगे तो this is sin I by sin R. Refractive index of medium 1 with respect to medium 2 is then uh, given as sin R by sin I. इसका हम लोग reciprocal ले लेते हैं. From equation 1 and 2, refractive index of medium 2 with respect to 1 into medium 1 with respect to 2 will give you sin I by sin R into sin R by sin I, which is 1. So refractive index of medium 1 with respect to 2 is 1 by refractive index of medium 2 with respect to 1. Or refractive index of medium 2 with respect to 1 is 1 by refractive index of 1 by 1 with respect to 2. तो ये बेसिकली क्या है, म्यू टू वन जो है रेसिप्रोकल ऑफ म्यू वन टू होगा, है ना. ना रिफ्रैक्शन ऑफ लाइट थ्रू अ रेक्टेंगुलर ग्लास ब्लॉक. ठीक है. So figure shows a rectangular glass block PQRS. Right. Now figure shows a rectangular glass block PQRS. A light ray AO falls on the surface PQ. तो ये हमारा incident ray हो गया. On the surface PQ, NOM is the normal to the surface PQ. So NOM is normal to the surface PQ at the point of incidence O. At the surface PQ, the ray AO enters from air, that is rarer medium, to glass, that is denser medium. So it slows down and bends towards the normal NOM. Now it travels inside the glass in a straight path along OB. Right. At the surface RS, the ray OB suffers refraction. So N1B M1 is the normal to the surface RS at the point of incidence B. The ray OB now enters from glass, that is denser medium, to air, which is rarer medium. So it speeds up and bends away from the normal N1B M1. It travels along BC in air. Now the ray AO is called incident ray, OB the refracted ray. So ray AO is called the incident ray, OB the refracted ray, and BC the emergent ray. Now, the angle AON is the angle of incidence I, angle BOM is the angle of refraction R, and angle CBM1, right, is the angle of emergence E. Now, since refraction occurs at two parallel surfaces PQ and RS, therefore, angle MOB is equal to angle N1BO, alternate interior angles जो equal होता है, ठीक है? And by principle of reversibility of the path of a light ray, angle E becomes equal to angle I, that is angle of emergent ray BC is parallel to the angle of ray AO. Now, lateral displacement. We observe that due to refraction of light at two parallel surfaces of a parallel sided glass block, the angle of emergence is equal to angle of incidence. So the emergent ray BC and the incident ray AO are parallel. That is, they are in the same direction, but they are not along the same line. The emergent ray The emergent ray is laterally displaced from the path of the incident ray. The path of the incident ray AOA is in absence of glass block has been shown in figure. तो ये जो AO को आप straight extend कर दोगे तो ये AOYD इस तरह से आता है, right? So shown in the figure by the dotted line OD. The perpendicular distance xy, which is equal to x between the path of emergent ray BC and the direction of incident ray OD is called the lateral displacement. So lateral displacement x depends on first the thickness of block or medium, second the angle of incidence, and the third refractive index of glass, and therefore also on the wavelength of the light used. Now dependence on thickness of medium. So more the thickness of medium, more is the lateral displacement. So directly proportional है thickness पे. Dependence on the angle of incidence. More the angle of incidence, more is the lateral displacement. Dependence on refractive index. More the refractive index of the medium, more is the lateral displacement. Since refractive index increases with a decrease in wavelength of light, so the lateral displacement increases with decrease in wavelength of light. That is, lateral displacement is more for a violet light than for the red light. Now, multiple images in a thick plain glass plate और थिक मिरर. तो बेसिकली अगर कोई ग्लास प्लेट है थिक सा, तो उससे जो images बनेगा, there will be multiple images which will be formed. So if a pin or an illuminated object is placed in front of a thick plain glass plate or a thick mirror and is viewed obliquely, a number of images are seen. Out of these images, the second image is the brightest, while others are decreasing, others are of decreasing brightness. ये 4A वाला पोर्शन है, तो मैं क्या करता हूँ, ये 4A वाला पोर्शन सेपरेट करके तुम्हें दे देता हूँ. तुम लोग का आज एग्जाम कैसा हुआ?
सर अच्छा गया।
कौन सा सब्जेक्ट था आज? मैथ्स था?
सर मैथ्स और इंग्लिश।
कैसा, मैथ्स में पूरे आ जाएंगे?
सर उम्मीद है।
सर ग्राफ में कोई
यस सर, कुछ गलत तो था नहीं, बट ग्राफ का लाइक फॉर्मेटिंग और वो सब हो सकता है इसमें से कट जाए।
सर पूरा पेपर मतलब सही तो था, बस ग्राफ रह गया।
ग्राफ रह गया?
सर मैंने बनाया था बट फिर मैंने उसको बीच में कुछ गलती से कुछ और मार्क कर दिया, तो उसको मैंने करा वो फट गया। फिर दूसरा बना रहा था, फिर टाइम भी अप हो गया, तो मैंने बाकी सारा भेज दिया, फिर ग्राफ नहीं भेजा।
क्या है यार, बना लेना चाहिए था, दूसरा लेके बना लेना चाहिए था फटाफट।
टाइम नहीं था सर, टाइम
सर
तो
टाइम नहीं था, लिंक चला जाता, फिर वो पेपर एक्सेप्ट नहीं करते हैं। तो सर मुझे लगा एक ग्राफ के चक्कर में फिर पूरा पेपर रह जाएगा भेजना, तो फिर मैंने बाकी भेज दिया।
चलो कोई नहीं। और माधव, तुम्हारा कैसा हुआ मैथ्स का पेपर? आवाज नहीं आ रही है माधव आपकी।
सर वो आई थिंक
अच्छा, सही था। अच्छा अच्छा, चलो गुड गुड। मतलब पहले से इम्प्रूवमेंट लग रहा है या फिर क्या है? ठीक है बेटा, और प्रैक्टिस करो, और है ना, जितना हम लोग क्लास में कर रहे हैं उसके अलावा भी घर पे खूब प्रैक्टिस करो, अपने आप अच्छा हो जाएगा। ठीक है। दूसरा वाला तो अब नेक्स्ट क्लास में तुम लोग को और कुछ पूछना है तो बताओ। कुछ न्यूमेरिकल्स कर लेते हैं, एक मिनट। जैसे यहाँ पे जो एग्जाम्पल फोर्थ अगर देखें तुम्हारे बुक में जो है, कह रहा है रिफ्रैक्टिव इंडेक्स ऑफ वाटर इज 4/3, सो म्यू वाटर इज इक्वल टू 4/3। कैलकुलेट द स्पीड ऑफ लाइट इन वाटर, हम लोग को निकालना है स्पीड ऑफ लाइट इन वाटर। स्पीड ऑफ लाइट इन वैक्यूम इज गिवन एज, ये हमें निकालना है। और c इज इक्वल टू 3 × 10⁸ मीटर पर सेकेंड। तो अब हम लोग ये रिलेशन यूज करेंगे, म्यू इज इक्वल टू c/v। तो रिफ्रैक्टिव इंडेक्स इन वाटर इज स्पीड ऑफ लाइट इन एयर बाय स्पीड ऑफ लाइट इन मीडियम, दैट इज वाटर। वैल्यूज पुट कर लो, 4/3 इज इक्वल टू 3 × 10⁸ बाय स्पीड ऑफ लाइट इन वाटर। vw इज इक्वल टू 3 × 10⁸ इंटू 3 डिवाइडेड बाय 4। 9/4 करेंगे तो 2.25 इंटू 10⁸ मीटर पर सेकेंड हो जाएगा। सो स्पीड ऑफ लाइट इन वाटर is equal to 2.25 into 10⁸ मीटर पर सेकेंड। क्लियर है बच्चों? फिफ्थ वाला जो है तुम्हारे बुक का एग्जाम्पल, उसमें कह रहा है रिफ्रैक्टिव इंडेक्स ऑफ वाटर इज 4/3, mu w is 4/3, and of glass is refractive index of glass is 3/2. What is the refractive index of glass with respect to water? So refractive index of glass with respect to water is refractive index of glass divided by refractive index of water. So which is equal to 3/2 by 4/3, which is 9/8, 1.125. सिक्स्थ वाला है ऑरेंज लाइट ऑफ wavelength 6600 angstrom. So lambda is equal to 6600 angstrom. traveling in air gets refracted in water. If the speed of light in air is 3 into 10 to the power 8 meter per second, 3 into 10 to the power 8 meter per second, and refractive index of water is 4 by 3. Find the frequency of light in air. ठीक है, पहला हम लोग को frequency of light in air निकालना है. V is equal, F is equal to, so frequency is equal to, एक तो speed is lambda into F, तो C by lambda हो जाएगा. So this is 3 into 10 to the power 8 divided by 6600 angstrom. So 6600 into 10 to the power minus 10. So this will give us 10 to the power 18 or here 16. 3 by 4.54 into 10 to the power 14 hertz हो गया frequency. उसके बाद second part में आपको कह रहा है the speed of light in water निकालना है. This is V is equal to mu is equal to C by V है, तो mu is equal to V is equal to C by mu water, which is equal to 3 into 10 to the power 8 by 4 by 3. 2.25 into 10 to the power 8 हो गया. तीसरा पार्ट कह रहा है wavelength of light in water. Lambda in water is lambda by mu water. So 6600 divided by 4 by 3, which is equal to 4950 angstrom. Clear है बच्चों? ये ए पार्ट हो गया हमारा. इसके आगे हम लोग नेक्स्ट क्लास में रिवाइज करेंगे. ठीक है, इतने दूर तक का नोट्स में भेज दूंगा तुम्हें. ठीक है बच्चों?
Yes.
ठीक है, चलिए फिर बाय एंड टेक केयर एवरीवन.
Bye, sir. Thank you.
Thank you, sir.